So thanks, guys. I changed the title of the slide at the last minute to be like more provocative. Like I'm a journalist by training, so we like to have good headlines. And distributing $350,000 through AI is a good headline. We've basically seen AI being used mostly as an assistant, but the actual decision is taken by humans. But here is a case where we actually make the decision get taken by the AI for deciding funds. So we're going to go through some of the smart ways to do it and some of the pitfalls of actually using AI to like distribute money to projects. This is the format of the talk, and I'll try being quick about it. So the first is the why, why are funding mechanisms important, and you can't just have everything decided by a committee. So this is Danny O'Brien from the Ethereum Foundation, who had this line called no SPOFs and no admins. And that basically means no single points of failure and no admin keys, which is a riff of the 1968 movement, no kings and no masters. So this is our equivalent in the Web3 space. But when it comes to funding, we always have a boss, or we always have a master who's deciding how much we are worth. And having some other mechanism other than a human deciding it is something which is valuable to fight for and keep this ethos. But we don't see too much of it in our space. So the what, what exactly are we proposing that, we can go about doing this? So the broad idea comes from Vitalik, where he talks about how we can use AI as the engine and humans as the steering wheel. And he basically lists out 3 approaches for using AI to distribute money to people. So the first approach on the left-hand side is make a single AI model, and we all work on that AI, and we hope that it yields a good outcome. This is usually a bad approach because if that AI sucks, if you don't upgrade it properly, you're basically using an inferior AI model to distribute money. On the right-hand side, we have futarchy, which I won't get too much into, but we are basically trying the second part, distilled human judgment, where AI can make a lot of decisions, humans can make a few decisions. So we use the few human decisions to select the AI which is most aligned, and it can make a lot of decisions. And it's like it's not just for funding. You can think of it as a new algorithm for social media, where you trust a certain group of people and their aesthetic preferences, and they give us a few preferences, and that selects the AI model, which then which then decides your feed, because those people's aesthetic judgments are good. So it's basically the idea of scaling human judgment, if I have to put it in one sentence. Now we come to the how. So we'll start from the bottom right of using AI in funding mechanisms. This was the point I said about humans are good at making decisions, but we can only make a few of them. AI can make many decisions, so we should combine the beauty of humans and AI through this format. And on the left-hand side, we have some features when we apply it to funding mechanisms. So the first is the cryptographic term of confusion, where when you're voting, you don't know exactly how that affects the outcome. If you have a clear link between your vote and the outcome, then it's a system that's easier to game in a cryptographic sense. And diffusion is that it's no one actor can have an overly large impact on the mechanism. So just because one person votes in a weird way shouldn't change the entire funding distribution. So confusion and diffusion. No security by obscurity is what we call Shannon's maxim, which is that every part of the system should be public except the private keys of its participants. So we shouldn't rely on the fact that the criteria by which we decide funding is only known to the grant committee. And we rely on this ignorance of the general world in order to be resilient. So it should all be public, and the cost to attack has to be greater than 0 in Sybil resistance, which I'll go into a bit. So that's kind of the broad overview of some of the features that we want. You'll see the top part in the trial run. So I won't go into the theory of it because now we're going to go into the actual trial run. So the first thing we did, we have to actually if we want to scale human judgment, we actually need to collect human judgment. We can't scale something we don't have. So this was the first challenge that we had. How do we collect good human judgment? So Vitalik came up with this idea. So I told him that hey, why don't you give 30 judgments between repos and nominate 2 people who can also give 30. And those 2 people nominated 2 and they nominated 2. And we ended up with this very beautiful tree of people who are experts in evaluating open source repos for Ethereum. So So that's how we ended up collecting about 700 comparisons between open source repos. So they looked at Go Ethereum, they looked at Solidity, and they say which one is more important, and they'll say Go Ethereum is more important. And with those 700 data sets that we collected, we ran a machine learning competition. So how many people here are familiar with Kaggle, Kaggle? Okay, so we have about like maybe 5-6 people that are familiar. So it's basically a competition where you have a ground truth data set, and AI models are trying to predict what that data set is. So you give 50% of the data as training data for the models, and you keep the other 50% as private for actually judging the models and like declaring the winner. So we used a Kaggle competition, and here we had the top winner was David Gasquez, who's also the data engineer at Filecoin. He was taking part as a hobby, and he had the least error score. So you can see the error scores over here. So that's David Gasquez. So that's one participant to kind of keep in mind who won and gets certain rights in the system of deciding money. And the other participant which we'll come to is number 10, which is Seer, which ran a very different process of how they got money. So just keep number 1 and number 10 in mind. So this is what the number 1 model came up with in its predictions of importance between repos. How many of you have heard of Protocol Guild? Okay, so that's about half the room. So Protocol Guild is a collection of all the repos which are consensus and execution clients of Ethereum. And they became famous with something called the Protocol Guild Pledge, saying that give 2% of your token supply to our guild to compensate the members. But now, because they were so successful, we've had many more guilds come up. The Argot Collective with Solidity. We had the Dev Tooling Guild with a lot of the programming languages and like Remix. So then the question becomes, how do I decide how much to give to Protocol Guild and how much do I give to other guilds? And that's basically what the winning model had to predict. And we selected the winning model by closeness to judge scores. So the top one was 14% Go Ethereum, 12.7% Solidity. And we created a drips list. So anyone can now allocate money here, and it gets distributed to all of these repos based on this percentage decided by the AI models. So this was like the trial run and the outcome, using the winning model. Simultaneously, with the same data of 700 comparisons, we started a prediction market on Seer, which was number 10 on the leaderboard, if you remember. So the prediction market was basically saying, if a judge evaluated this repo, what score would the judge give it? So like prediction markets don't always have to be for objective events, like who is going to be the next president of the US. They can also be for subjective events. Like if a committee evaluated this project, what score would the committee give it? You can have a prediction market also on that. So that's basically what Seer did with like at the same time as the competition, and they submitted their results on the prediction market in the competition itself. And you can see how wildly the graph swung over time. Like, so if you look at the red graph there, Argot, there was like a big spike in the red line over there on the left side. That's because someone tried gaming the system and giving extra money to one repo, but then very quickly the market brought it back down. So we had like a lot of fun with this and like prediction market, and like some model builders even got twice the amount of money which they put in. So you upload your same answers which you're uploading in the competition. You upload those same answers on the prediction market, but you basically can put money behind your predictions, and that changes the price on the prediction market. So this was the results from the prediction market, where you have like the different repos and what weights they got. And on the right-hand side, you have the average of the judges' results. So how many of you like are experts on like Ethereum and you can actually make judgments between these? Okay, there's one over there. So yeah, maybe we'll ask you like, which of these, do you think the left-hand side or the right-hand side? Like if left hand, put your hand up, and or right hand, then like don't put it up. Like which do you think is better between the two distributions? Hard to tell, yeah. But the cool part is, yeah, go ahead. Yeah, like, do you have a preference? Left hand, left one, left hand, right one, right hand. Yeah, okay, I see some left hands. I see a right hand. I see a right hand. Wow, okay, so people did prefer. So the right one is the average of the judges' results, which resolve the market and determine profit and loss of the traders. And on the left-hand side is what the market finally settled at the close once we ended it. And the coolest part of this all was when we showed these results to the judges who were nominated by Vitalik and they nominated too, that entire tree I showed you, they actually preferred the results on the left-hand side. So they preferred results which were not an average of their own scores, because my personal decision is that, like my personal opinion is, when you average out the results of many humans, you always descend into mediocrity. And when you actually let one person drive a unified vision, that usually that achieves excellence. But whose one vision do we select is the hard part to decide. So that was interesting. And now basically we are running with that experiment. So this is now where we are today. Like, this was all just catching you up on the pilot and the trial run. This is where we are right now, where we've got 350K to distribute via GG24, half from EF and half from Gitcoin. And so the first part is that many more repos applied to join the round, because the earlier set was just those 3 guilds. So how do we decide which repo is allowed and which isn't? In a lot of the funding mechanisms, I've seen that a lot more innovation has happened in allocation compared to eligibility. But who gets to take part in the round is actually way more important than the allocation, because if only good projects are in the round, it doesn't matter if your allocation is a bit off, because the money is going to good projects anyways. So here what we did was something cool. We got a list of 275 repos, and because of something called Zipf's law, we have to restrict it to 128 repos, like the overall set that can compete in the round. So how do we decide which of the repos to actually select and which to reject? And that's where we use David Gasquez's model. He was the winner of the last contest. So with the entire new list of 275 repos, we ran David Gasquez's winning model and then came up with like a list of 60 additional repos to add to the list. So that was like a really cool way of doing eligibility in a decentralized way. But there are some issues with this, which I'll return to in the last slide. Yeah, so this is how we need your help today. We have selected the repo. So number 3 is complete because we chose the winning model and narrowed down the list that takes part in the round. But we need people who, how many of you here are like AI builders or have experimented with using AI? So we have like 2, 3, 4 people here. So we actually need your help to take part in these competitions, like give prompts to your AI. And we have prizes for you open sourcing your AI model, doing a write-up of how you designed your AI. So you can see David Gasquez's model on GitHub. You can literally recreate David Gasquez's model and like make tinkering changes to it and like, and score pretty highly and make money on the prediction market. So that's how we need your help if you're an AI builder, like actually submit good models and take part in it by trading on the value of repos. How many of you are open source evaluators? You think you can make good judgments on importance of repos and you're like pretty good at developing work? Oh, wow. Okay. That's quite a few numbers here. So eight people around. So this is where we need your help, where we have like a voting app where you compare one repo with another, and that becomes the ground truth data, which then selects the winning model or determines the profit and loss of the models in the market. And now for the first time, we've made it open to anyone. So any of you, as long as you have an ENS name, because the cost to attack should be higher than $0. So ENS name requires $5. So with your ENS name, you can log into the app and make comparisons. And that committee you saw earlier, the one with Vitalik and the full tree, that has now become a meta juror committee, which will review your comparisons and only select them if you actually make sense. If you just say that I belong to this team, so I'm giving it a high rate, then the meta juror committee will think you're an idiot and eliminate your comparison. So it's actually a cool way, like, if Vitalik chooses your comparison, that's like a great thing, So we need your help even as an evaluator. So that's the other way we need your help. So open source evaluators, AI builders to bet on the market, and like new pilots, like just like we're looking at, like Juan Bennett said on stage, he's looking at running these competitions. So I think having more such like horizontal scaling with more ecosystems using this technique where you're not building your own AI, but you're running a competition for any AI developer to contribute, any AI model to be submitted. I think that's the kind of broad angle we want. Now we come to the frontier, like, what are the open design questions? And this is the last slide. I think the most fundamental and philosophical question in all of this is, how do we even best obtain human judgment? Because a lot of the model builders said that the data is not statistically significant, which we collected. So it really generated a lot of noise. And I don't know if that's because our method of collection was bad or because humans just disagree a lot. But I think that's something which we are trying to figure out. How do we best collect? So some of the working hypotheses are that the top repos take majority of the funding. So we should have more evaluations on the top and much less on the long tail. Like there should be much less evaluations there. So it's called multi-arm bandit for those who are who know like that full theory in computer science. Second is a local view only. So if I asked all of you, what is the most expensive object in the room? Some of you might say the screen because that's the first thing you're seeing. And then you might look around and say, okay, these lights. And then you might say something else. So when you ask for a global view, you always end up getting bad human judgment. But if I just asked you a question like, is the screen more expensive or are the lights more expensive? You can usually make a better judgment. So that's what we should use to select the AI model. And the last is just removing intensity. We asked jurors how much more valuable is solidity over Go Ethereum. And that's where we encountered a lot of logical errors in the data, where one juror would say 100x, another would say 10x. So that like the intensity, like humans are bad at quantification, but they could be good at pairwise. So what's another thing we're looking at? Removing intensity. Sybil resistance and ENS names to kind of have some form of resistance. Otherwise, as a model builder, you can submit 1 million models and one of them is bound to be right. So how do we create some Sybil resistance on that front and with the jurors since we're opening it up? The third point is actually very hard and I've not made any progress at all on it, which is, so if I give the example of Optimism's retro funding round, there was a project which got $1 million and then Optimism asked them that, hey, is it okay if you can integrate this new chain into your app? And then that app replied, yeah, that'll be $40,000, please. And the Optimism team was like, dude, we literally gave you $1 million a month ago. And they're like, oh, that was retro funding. It doesn't count. So I think like if they had structured the same deal with like a grant administrator, they would have got much higher bang for their buck compared to giving it as a retro funding. And that's a problem we haven't solved. But that's what's holding funding mechanisms back today. The perception that you get a better bang for your buck if you actually have someone talking and making sure of it. Like meta mechanism to select from amongst many weights. Like this time we're going with the prediction market for GG24 because it enables more traders. And like, I think the idea is your attempts to game the system are my profit margin. Like that's the system we want. Where in Gitcoin quadratic funding, if you try gaming the system, at the worst case, you just won't get extra matching funds because they've caught you. But in this case, if you try gaming it, like another trader is going to take the money from you. So your attempts to game the system should be the trader's profit margin. But like at a broader level, should we select David Gasquez's model or the prediction market weights? And that's a thing we need to figure out. So one idea is only measure based on the ordering. So if David Gasquez's ordering of number 1 repo, number 2, number 3 is more accurate than the prediction market ordering of repos, then the weights of David Gasquez get chosen because his ordering was more. So that's called ordinal and cardinal weights. This is the last point. You can reach out to me on Telegram, Twitter. I write every day here, and on Signal. But the last point is really accurate dependency graph generation. And this is the part that's hardest to actually figure out or at a design level, which is technically in the list of 275 repos, if Solana submitted one of their open source repos, David Gasquez's winning model would probably have rated it highly. And the reason for that is that Ethereum is an abstract concept. It's a movement. It's not a concrete digital artifact. Like say Go Ethereum. Go Ethereum is a digital artifact. So judging relevancy to an abstract movement is very hard compared to judging relevancy to a digital object. So like getting the accurate dependency graph for abstract, a non-digital object represented things like Ethereum is like another hard part to figure out. And just like a lot of the dependencies, like maintainers said, are not relevant to us. So like creating a collaborative layer for that. So yeah, these are the open questions. Please message me if this was interesting or you want to take part in any way. Is there time for questions or are we over?
1 minute.
Okay. 1 minute. Yeah. 1, 2 questions if there are any. You can just take both questions together. So you and then Monte. Yeah.
Will you ask for help into the way from the system that's directly linked to Seer prediction.
This one, right? Oh,
Uh, no problem.
yeah. Yeah. Oh yeah, so you just have to go to the like a website called deep.seer.pm. So deep.seer.pm, and then you have to just upload a CSV file with the list of repos and your predicted weights, and then that will tell you what its market price at the moment is, how that diverges from your model's predictions, and you can then stake money on the difference between the two and make money once the market gets resolved. Yeah. PM. PM, yeah. Monty, quick? Yeah.
Yeah, I was just wondering about how you see like human evaluations and how AI also plays a role in that. Because in some ways it can augment human evaluations, but in other ways it can like detract from it because people might just like rely on the AI's evaluation and almost become lazy. And how, you know, if they're just letting the AI influence of using your own design judgment, and in a way you're like increasing the quality of human part of it. So there's like a kind of delicate interplay of like how exactly you leverage AI for all the benefits it can versus like, yeah, the risk.
Yep. Yeah, I think the risk is that you become a circular system where AIs are trying to predict what another AI is doing, which is like not what you want. Yeah. Right. But the way we've used it here is basically the winning model or the winning AI sets the base rates for the prediction market. So for those who know, like prediction markets, it's important to set a good base rate, which is the rate at which the market begins. Because if your rates are too off, then you lose the liquidity that you put in. And if they're too correct, then there's no profit arbitrage that traders can make. So they don't really have an incentive to participate. And if you put too much liquidity, then the prices don't change when people upload. And if you put too little liquidity, then the prices change very wildly for even like a small upload. So that's like, so this is how we use AI. We use AI to set the initial base rates, which then kickstart the prediction market and allow people to do it. So we get like the winning model shows the base rates over here, as you can see in this one. Yeah.